Hi, good morning to all. This is Srikanth Reddy, lecturer in Electronics and Communication Engineering, working at Government Polytechnic, Jogupet. Subject name Microwave Communication and Television. Subject code ECE 405. Today we discuss the topic working of satellite communication. Subtopic apogee, perigee, azimuth angle and elevation angle, uplink frequencies, downlink frequencies of satellites. Objectives. On completion of this topic, you would be able to understand uplink frequency and downlink frequency, apogee and perigee, azimuth and elevation angles. Some of the definitions of satellite communication system. Definition of apogee. When the satellite is in an elliptical orbit, the farthest point from the earth of that orbit is called apogee. The distance between the center of the earth and apogee is called apogee distance. Here the diagram shows, if we take as earth at center, if the orbital is an elliptical orbital, the satellite is rotating on the earth on a different orbitals. These orbitals are in elliptical in nature or an elliptical assumption. In this, the farthest distance from the satellite to earth station, or the maximum distance from earth to satellite, is called as apogee. The apogee distance is the distance between earth center to the satellite is called apogee distance. Here it shows the diagram. Here earth is center, then the orbit is in elliptical orbit. The satellite is rotating in the elliptical orbit. The satellite is in farthest distance or maximum distance from earth to satellite is the right side. So this distance is called apogee distance. This is called apogee. Definition of perigee. When the satellite is in an elliptical orbit, the lowest point from the earth of the orbit is called perigee. The distance between the center of the earth and perigee is called perigee distance. Similar, the satellite is rotating on elliptical orbit, then the smallest distance are the lowest point from the Earth station to satellite, at the lowest distance, at the lowest point, are near to the Earth from satellite to Earth is called as perigee. The distance between Earth center to the satellite, which is near distance or small shorter distance, is called as perigee distance. Here, apogee and perigee are used to find satellite location. So, if the orbital is elliptical, the apogee is the farthest distance, perigee is the smallest. If we assumption the orbital is in circular, then apogee and perigee is same. That means apogee distance is equal to the perigee distance when satellite orbit in circular orbit. Here, Earth to satellite nearer distance from, we show the diagram by the left side. Here the satellite and Earth is nearer or smallest distance, then that is called as perigee distance or perigee. So these two are the apogee and perigee. Look angles. The look angles are the angles to which an earth station antenna must be pointed to the communicate with satellites. So these are angles are used to communicate with the satellite to earth station. So this is used to pointing the position of the earth station to satellite position. So it is a pointing. This shows the pointing or which angle it is shown, which angle it is there. It can be measured by the look angles. So these look angles are two types: elevation angle, azimuth angle. These are calculated based on the knowledge of latitude and relative longitudes. So, that means look angles are used to measure the or pointing the position of the satellite from the earth station. These are two types. Look angles are the elevation angle and azimuth angle. These are calculated based on the knowledge of latitude and relative longitudes. Latitude and longitudes are used to measure the look angles or satellite position from earth station to satellite. Elevation angle. The angle of elevation of satellite is that angle that appears between the line from earth station antenna to satellite and line between earth station antenna and earth origin. It is the angle that appears between the line from earth station antenna. Here, elevation angle is the angle which is used to measure the angle of appears between the line from the earth station to the satellite and line between the earth station antenna to the earth origin. So the elevation angle is the horizontal angle from Earth station to satellite. The angle that appears between the line from Earth station antenna to satellite. Azimuth angle. The azimuth refers to the direction where the north is equal to the 0 degrees. The azimuth is measured clockwise with respect to north. Here, azimuthal angle is refers to the direction of the satellite from north onwards. So, north is equal to 0 degrees when the angle is measured in clockwise direction with respect to north. Then the satellite angle to the Earth station is measured in azimuthal angle. Here, the two diagrams. First one is elevation angle. Here, the angle pointing to the horizontally from Earth station to satellite is called as angle of elevation. Here, azimuth angle, it is the angle from vertical from satellite to Earth to satellite, but which refers to the direction where north is equal to 0. This means north onwards it can be stopped when it is rotating as measured in clockwise direction with respect to north point. So these two are the elevation and azimuthal angles. Once the azimuthal and elevations are known, the station of antenna can be pointed in the direction. So, by using elevation and azimuthal angles, easily find out the Earth station antenna can be pointed directly to the pointer in the direction of satellite. For a geosynchronous satellite, the antenna will remain in the position. In geosynchronous or geostationary satellite, the antenna will remain in that same position because in geosynchronous satellites, the satellite rotation is equal to the satellite rotation is equal to the rotation of Earth. So that is 24 hours per day. In this way, the Earth rotation is equal to the satellite rotation. Then the Earth and satellite always shows the stationary or constant. So that way it is called as geosynchronous satellite or geostationary satellite. In this geostationary satellite, the position of the satellite is always it shows constants remain in that position only. For any other satellite, the antenna must be moved as the satellite passes overhead. So another satellites, non-geosynchronous satellites or other satellites are used to other satellites are antenna must be moved as the satellite passes overhead, which shows the angle perfectly. So these two are the azimuth and elevation angle. These two angles are used to measure the satellite direction by using longitude and latitude values. Next topic, satellite frequency bands. The microwave frequencies are from 1 GHz to 700 GHz. These frequencies are used for satellite communication. These frequencies are used for satellite communication. These total frequency bands is divided into some groups or some categories. Some bands are there. Some bands are used for some particular application. In this signal way, the total frequency spectrum of satellite communication are divided into some bands. These bands are L band. This L band range is 1 GHz to 2 GHz. S band, this range is 2 GHz to 4 GHz. C band 4 GHz to 8 GHz. X band 8 GHz to 12.5 GHz. Ku band 12.5 GHz to 18 GHz. K band 18 GHz to 26.5 GHz. Ka band 26.5 GHz to 46 GHz. These are the satellite frequency bands used for different applications. Depending on the application, we can divide into some bands, some ranges. So in satellite communication, we use the micro frequency range from 1 GHz to 700 GHz, approximately 300 GHz range we can use. Here 1 to 46 GHz range are divided by LS, CX, KU, K and KA bands. And that these are the some ranges of bands. Satellite link. Here, satellite link is a frequency used to transmit the information and receive the information. So here we in earth station onwards we can sending the information or transmitting the information towards the satellite, and the satellite receives signals and it's amplifying or processing or observing, and these signals are returned back to the earth station. So here receiving antenna is taken the receiving signals from transmitting signals from satellite. So the earth station is used to transmit the signals, satellite is receiving, and satellite is transmitting signal and receiving station is receiving. Here how much frequencies are used to transmit, how much range frequency are used to transmit from earth station to satellite, and satellite to earth station is known as satellite link. Here we use uplink and downlink. Here the signals are transferred from transmitted antenna to satellite is called uplink, or the signals transferred from satellite to receiving antenna is called downlink. Satellite uplink. An uplink is the transmission of signal from an earth station to satellite in orbit. So uplink frequency is a frequency, or uplink frequency is known as to transfer the signal from earth station antenna to satellite up in orbit. So here we can transfer the signals from upward direction earth to satellites. So this uplink frequency from C band and Ku band. C band we use as 6 GHz and Ku band we use as 14 GHz. Satellite downlink, and downlink is the transmission of signal from satellite into earth station. So here the frequency or signals transfer from satellite to earth station. So here satellites are transmitting signals, earth station is receiving signals. So this downward direction satellite to satellite which has some orbit which transmit the signals to earth station. So these are called downlink frequencies or downlink signals. So here Ku band is 2 GHz for downlink and C-band is 4 GHz per downlink frequency. So here two bands are morely used, C-band and Ku band. C-band are used for uplink frequency GHz and C-band used for downlink for 4 GHz. For Ku band, uplink frequency is 14 GHz and downlink frequency is 12 GHz. In this way, the satellite and uplink and downlink frequencies are categories. Here, transmission station is giving to signals from transmitting antenna to satellite. So, this is called as uplink frequency 6 GHz. When the signals are transmitting from satellite to receiving antenna is called downlink frequency or downlink. Uplink is approximately 6 GHz, downlink is 4 GHz or C band. We can more used communication service. So this is the idea. An earth station transmitting information to satellite. Here the earth station is used to transmit the information to satellite. The satellite contains the receiver which pick up the transmitted signal and amplify the signals. So here the satellite is used to receiving the signal from the transmitting antenna, and these received signals are recorded by the transmitting antenna of satellite, and the signals are amplified or processing, and to amplify the signals are processing signals are transmitted channelizations. This transfer the new frequency called as uplink frequency. So from earth station to satellite, this frequency is called uplink frequency. The signal being transferred from earth station to satellite is called uplink. So here the signal transfer from earth to satellite is called as uplink frequency. We transfer the signal from satellite to the receiver earth station is called downlink frequency. So here downlink frequency is the satellite is receiving the signal from the earth station, and the signals are amplified or processing and which return to the earth station. Here earth station is receiving the signals from the satellite. So here the signals are transmitted from satellite orbit to earth station. Then these signals are called downlink signals or downlink frequency. So for C-band, uplink frequency range is 5.925 GHz to 6.425 GHz, approximately taken as 6 GHz range. Here, downlink frequency range is 3.7 GHz to 4.2 GHz, so approximately taken as 4 GHz. So C-band uplink frequency is 6 GHz, downlink frequency is 4 GHz. For Ku band, uplink frequency is 14 GHz to 14.5 GHz, downlink frequency is 10.7 GHz to 12.2 GHz. So here uplink frequency taken as approximately 14 GHz, downlink frequency is taken as approximately 12 GHz for Ku band. So in this way, C-band has uplink frequency 6 GHz, downlink frequency 4 GHz. Ku band, the uplink frequency is 14 GHz, downlink frequency is 12 GHz. Typical antenna sizes. Here, the antenna size. Here, satellite has, we can use in earth station antenna, also have antennas, and satellite has antenna also contains antennas. So here earth station contains antennas for transmitting as well as receiving. Here morely used earth station antennas are parabolic reflector antennas or dish type antennas are used. parabolic reflector antennas or distant reflector antennas are useful. So for C-band, the antenna diameter is approximately 1.8 meters to 3.7 meters. So the antenna diameter is here 1.8 to meters to 3.7 meters. So for C-band, the antenna parabolic reflector antenna or dish antenna diameter is 1.8 meters to 2.7 meters. For Ku band, the antenna diameter is 1 meter to 1.2 meters. 1 meter to 1.2 meters. By observing these two diagrams of C bands and Ku bands, C band for 1.8 meters to 3.7 meters and Ku band 1.0 meters to 1.2 meters. For C band range, we used 6 GHz of frequency and 4 GHz for downlink frequency. For Ku band, 14 GHz for uplink frequency, 12 GHz for downlink frequency. So here C band compared to C band is less frequency compared to Ku band. So it has less frequency, we have more the diameter range of antenna. So here antenna size is more for C band compared to the Ku band. Here C band is 6 GHz. So the antenna size is approximately 2 meters to 4 meters. Here Ku band we used 14 GHz to 12 GHz, 14 for uplink frequency, 12 for downlink frequency. What is it? So the Ku band, the antenna size or parabolic antenna reflects this antenna size is 1 meter to 1.5, 1.2 meters compared to C band. This antenna size is very less, half of the size. So these are the typical antenna sizes of satellite communication. So these are the typical antenna sizes. Once we can revise the today class. We discuss the topics uplink and downlink frequencies, apogee and perigee, azimuth and elevation angles. Definition of apogee. When the satellite is in elliptical orbit, the farthest point from Earth of the orbit is called apogee. The distance between the center of Earth and apogee is called apogee distance. So here the diagram shows here the Earth is the center. The satellite rotates in elliptical orbit. If the satellite is in elliptical orbit, then the satellite comes one of the situation which comes from near to the Earth, and some of the time it's far or longer distance from the Earth. In that situation, the two situations nearer to and longer distance it reaches. The nearer distance is called as perigee and larger distance is called as apogee. That means if satellite is in elliptical orbit, the Earth to the satellite which has maximum distance or farthest point. The farthest point from Earth to satellite orbit is called as apogee, or the distance from Earth center to farthest point of satellite is called apogee distance. It means Earth center point to maximum distance from orbit satellite from a orbit. So it is called apogee distance. Here shows the diagram. It is the apogee distance from right side Earth to satellite. If the satellite from moving in elliptic orbit, the smallest distance or nearest point to the Earth to satellite, nearest point for Earth to satellite is called perigee. So here the distance is near. Here the distance from Earth center to nearest point of satellite is called perigee distance. The two distances are called apogee and perigee distance. When the satellite is in elliptical orbit, if the satellite orbit is in circular, then apogee and perigee is same, or the apogee distance and perigee distance are equal. When the satellite is in a satellite rotates in a circular orbit. So these are the apogee and perigee, apogee distance and perigee distance. Here the Earth is the center and left side it is a smallest distance or nearest point from Earth to satellite is called perigee, and the distance nearest distance from Earth center to satellite point or in a orbit is called as perigee distance. Next, look angles. The look angles are the angles to which Earth station antenna must be pointed to communicate with satellites. So the look angles are used to pointing the satellite to Earth or pointing the satellite position in a orbit. The look angles are used to pointing a satellite from Earth to for communication purpose. So these look angles are mainly divided into two types: elevation angle, azimuthal angle. These are calculated based on the knowledge of longitude and latitude values. So latitude and longitude values are used to measure the satellite position when the satellite is rotating in the orbit, which position the satellite is there, or which angle it is from Earth station to satellites for communication purpose. So here we communicating from Earth to satellite, how much the satellite rotates, for which direction or which point the satellite is exists for communication. So this information is used to measure by the look angles, elevation and azimuth angle. Then only we can communicate with Earth station to satellite. So the look angle is elevation angle and azimuth angle. Elevation angle. The angle of elevation of satellite is that angle that appears between the line from Earth station antenna to satellite and the line between the Earth station antenna and the Earth origin. Here the elevation angle is the horizontal angle pointing to the Earth station to satellite. Horizontal angle pointing to Earth station to satellite. It is the horizontal angle means here elevation angle satellite is that appears between the line of the Earth station. So here the line of the Earth station to station antenna to satellite, and the line between the earth station antenna and earth origin. So it is simply called as, simply says, it is the horizontal point to the earth station antenna to satellite is called elevation angle. It is the angle that appears between the from earth station antenna. Here, earth to satellite by the horizontal angle is called angle of elevation. Azimuth angle. Azimuth refers to the direction where the north equal to 0 degrees. That means it is used to find the vertical direction to the earth to satellite. Here, if the earth is center point, then vertical direction are north equal to the 0 direction. When the satellite rotating in north direction, we take it as the 0 position to how much angle the satellite is exist by measured in clockwise direction. So azimuth is measured clockwise with respect to north onwards. So this is to measure the vertical angle. So azimuth and elevation angle two are used to measure the direction of the satellite or angle of the satellite from earth station. Once the azimuth and elevations are known, the earth station antenna can be pointed in the direction. Then azimuth and elevation angle values are known. Then the satellite is pointed to the earth station, or which how angle it is there from earth to satellite, or how much distance from earth station to satellite. For geostationary or geosynchronous satellite, the antenna will remain in the position. So here the earth station antenna to satellite antenna are equal distance or same way, then only we can transfer the information. So the earth station to satellite antennas positions are used to finding by azimuth line elevation angle. If the satellite in geostationary orbit, then the satellite is launched in geostationary orbit, then the satellite velocity is equal to the velocity of earth. Then always the satellite shows the constant to the geostationary satellite or stationary to geosynchronous satellite. In this way, the satellite and earth is constantly shows. So remember that position is same position. Then that is called as geosynchronous satellite or geostationary satellite, because the geostationary satellites are the satellite rotation is equal to the earth rotation. For any other satellites, the antenna must be moved as the satellite passes overhead. For other satellites, the satellite position is varied or changed passed overhead. Silent frequency, satellite frequency bands. Here, satellite used as microwave frequencies. So, these microwave frequencies are divided into 1 GHz to 700 GHz. So, these frequencies are divided into some categories or bands depending on the applications we used or need. So, here the frequency bands are L band, that range is 1 GHz to 2 GHz, S band 2 to 4 GHz, C band 4 to 8 GHz, X band 8 to 12.5 GHz, Ku band 12.5 GHz to 18 GHz, K band 18 GHz to 26.5 GHz, Ka band 26.5 to 46 GHz. So these are some satellite frequency bands. In this, say C band and Ku band are morely used propagation. Satellite link. Here, the transmitting the signals from Earth station to satellite is called as uplink frequencies. The satellite, when satellite in orbit, the satellite transmitting the signals when the Earth station is receiving the signals. Then it is called as downlink signals. Uplink means the signals transmitted from Earth station to satellite. Then the satellite receiving the signals from Earth station and the signals are processing, are amplified, are channel allocations, then retransmitted to the satellite to Earth station. So here Earth station is receiving it. So here satellite to Earth station is called downlink frequency or downlink. So here uplink and downlinks are used to upward direction. Earth station to satellite is uplink, satellite to receiving antenna, receiving Earth station is downlink. For C-band, 6 GHz from uplink frequency, Ku band, for 4 GHz for downlink frequency. For Ku band, 14 GHz for uplink frequency, 12 GHz for downlink frequency. These are the satellite links. Here uplink is the transmission of signal from Earth station to satellite orbit. So upward direction. Earth station to satellite is called uplink frequency or uplink. And downlink is transmitting the signal from satellite to Earth station. Satellite to Earth station. So orbit to Earth station. So it is a downlink. Satellite link. Where upward direction or downward depending on here transmitting the signals from Earth station antenna to satellite communication is called uplink frequency, approximately 6 GHz for C-band. The signals are receiving from satellite to receiving antenna is called downlink frequency, approximately 4 GHz for C-band. An Earth station transmits the information to the satellite, and the satellites contain the receiver's antenna, which picks up the transmitted signal, and these signals are amplified, are processing, are channel allocation, and then will again retransmit to the Earth station. So the transmitters of the new frequency called as uplink frequency. The signal being transmitted from Earth station to satellite is called uplink, and retransmit the signal from satellite to receiving Earth station is called downlink. So these are the uplink and downlink frequencies. C-band and Ku-band. So C-band for uplink frequency is 5.925 to 6.425 GHz, approximately 6 GHz. Downlink frequency 3 GHz to 4 GHz. So downlink frequency approximately 4 GHz. For Ku-band, uplink frequency 14 GHz to 14.5 GHz, so taken as 15 GHz. Downlink frequency 10.7 GHz to 12.2 GHz, so downlink frequency as 2 GHz. Typical antennas for C-band and Ku-band. C-band we have 6 GHz, uplink, downlink 4 GHz. So the antenna here used as dish antenna or parabolic reflector antenna. So here the range is 1.8 meters to 3.7 meters of diameter of antenna size. For Ku-band, 1 meter to 1.2 meter of diameter of antenna. So a Ku-band frequency is 14 GHz and 12 GHz. 14 for uplink frequency, 12 for downlink. So the antenna size decreases 1 meter to 12 by. For C-band, 6 GHz to 4 GHz uplink and downlink. Then antenna size is 1.8 meter to 3.7. So increasing the frequency levels, diameter of the antenna is decreasing. So in this way, the antenna's sizes are designed. For high frequencies, the antenna size decreases. For low frequencies, the antenna size increases. Here, the antennas are used as dish antennas or parabolic reflector antennas are used. So, in this we learn about different definitions like apogee, parallel, azimuth angle, and elevation angles, uplink and downlink frequencies of satellites. Thank you. Thank you to all.